Recording started.
All right, last time I think we talked about a sequence. And remember, a sequence was just a sequence of numbers, like say 2, 4, 6, 8, so on. That was a sequence. Easiest way to define a series is to say that you just add up or find the sum of a sequence. So instead of just a list of numbers, if I said 2 plus 4 plus 6 plus 8, so on, that is a series. That's an example of an infinite series. But we can also have a finite series. So here we go with notation. If you see the big letter S, that letter S means the sum, and the subscript tells you how many. So this means the sum of the first 4 terms. That S sub 4 means the sum of the first 4 terms. And here is the sequence that we're going to be adding up. So in order to find S sub 4, the first thing I have to do is find each of the 4 first terms. So A sub 1 is 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. So A sub 1 is a 3. A sub 2 would be 2 times 2 plus 1. 2 times 2 is 4 plus 1 is 5. A sub 3 should be 2 times 3 plus 1. That's 7. And A sub 4 in this case would be 2 times 4 plus 1. So that would be a 9. To find the sum, I'm just going to add those up. I total those up. Let's see, that's going to be 24. That is S sub 4, the sum of the first 4 terms of the sequence. That's the series. Right. For an arithmetic sequence, the sum of the first n terms, so the sum of the series, will be this one. The number of terms times the first term plus the last term. A sub 1 is the first term, A sub n is the last term, divided by 2, and then of course multiplied by the number of terms in the series. So for example, if we're going to find the sum of the numbers 2 plus 4 plus 6 plus 8 plus 10 plus 12 on out to 100, first I need to know some terms. So A sub 1, certainly we know that it's a 2. We know that if we were adding up all of the numbers between 1 and 100, that's 100 numbers. So since we're adding up the even numbers, our n, the number of terms, has to be half of that, so that'll be 50. And we also know the last term is 100, that's A sub 50 is 100. So let's see, we can put that into our formula right now. So the sum of the first 50 terms is equal to 50 times 2 plus 100 divided by 2. So let's see, what do we have here? We have 50 is equal to 102 divided by 2, and of course 102 divided by 2 is 51, so we have 50 times 51, which turns out to be 2,550. So that is S sub 50. Sum of the first 50 terms is 2,550. Triangle. If you have a geometric sequence, the sum of the first n terms is given by this formula. A again is the first term. R is the common ratio, not the common difference. That's for arithmetic, common ratio. Let's look at an example. Let's say I'm going to add up the first 4 terms of the following series. So it's 3 minus 6 plus 12 minus 24. Let's see. I know what the first term is, A sub 1. is a 3. But now let's look at a common difference, so our common ratio. It looks to me like when I multiply it here, 3 times 2 would get me a 6. Well, and we need to make it a negative, so 3 times negative 2 would get me a negative 6. Negative 6 times a negative 2 would get me a positive 12. Positive 12 times a negative 2 would get me a negative 24. So it looks like my common difference, my common ratio is negative 2. All right. So the sum of the first 4 terms, those terms we've got right here, is going to be the first term, 3, times 1 minus r, which is negative 2, raised to the 4th power, divided by 1 minus r, again is negative 2. Let's see, what do we have? I've got 3 times 1 minus, let's see, negative 2 raised to the 4th power is a positive 16. So 1 minus 16. On the bottom, minus a minus becomes a positive, so that's 1 plus 2. Let's see, I have 3 times negative 15. 1 minus 16 is negative 15, divided by 3. Well, negative 15 divided by 3 is just a negative, well, it's a negative 5. So I have 3 times negative 5, which is equal to negative 15. So the sum of the first 4 terms in that series turns out to be negative 15. And of course, you're probably saying to yourself, you could just add these guys up, and sure, you could. But this is the formula that you'll use even if it's something larger that you can't add up easily in your head. Now, most geometric series are going to just get larger without bounds. They're going to get bigger and bigger and bigger as you add more terms to them. But some infinite geometric series will actually get closer and closer and closer to a specific number. But this only happens if the common ratio is less than 1, if the absolute value is less than 1. If that happens, then when you add up an infinite geometric series using this formula, you'll get just a nice number. Let's try it. So here we go. I have this infinite series. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and it keeps on going out forever and ever. So we can add 1/64 and 1/128. Let's take a look here. I know what the first term is, and I think I know at least what my common ratio is. It looks like I'm multiplying by 1/2. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. So it looks to me like all I need to do is tell you the common ratio. Common ratio is 1/2. Tell you the first term. The first term, a sub 1, is a 1. So the sum is going to be the first term, 1, divided by 1 minus the common ratio, which is 1/2. So I have 1 divided by 1/2. And I'm going to rewrite that as 1 times 2 over 1. So that's just a 2. If I add up this infinite series, it'll all add up to be just a plain old 2. Now this only works again because I know that my R value, my common ratio, is less than 1. Last stop, the big sigma, summation notation. This is notation you're going to see a lot, especially later on in calculus, but it's the uppercase sigma, which looks like this. And the notation will be like this. You'll see a little variable on the bottom, like k equals 1, and then up on top it'll be another number. So this is saying k equals 1 to 4, and then it'll tell us here what we want, what k will be equal to. So will be k squared, and I'm going to evaluate that from 1 to 4. So what I'll do is I'm going to say, when k is a 1, I get 1 squared, plus, and that's what the sigma means, to add them all up. When k is a 2, I'll get 2 squared. When k is a 3, I'll get 3 squared. When k is a 4, of course, I'll have 4 squared. I stop at 4 because that's what my notation says to do. It says to run from 1 to 4. So if I add all these up, that's 1 plus 4 plus 9 plus 16. That gives me a grand total of 30. That's summation notation. Let me show you another one. So here's my sigma. And this time we're going to run from 3 to 5. You don't have to run from 1. You can run from 3 to 5. And then I'll tell you what k will be. So this will be 2k minus 5. And again, all we're going to do is plug these numbers 3 through 5 in for k and add them all up. So let's see, the first one will be 2 times 3 minus 5. The second one will be 2 times 4 minus 5. And the third one will be 2 times 5 minus 5. These are all multiplied. So let's see what we get. 2 times 3 is 6 minus 5 plus 8 minus 5 plus 10 minus 5. Let's see, that's going to be 1 plus 3 plus 5. So that's going to give me a grand total of 9. So using this summation notation, which is just the uppercase sigma, I'm going to run from this low number 3 up to this high number of 5. And just plug that in, add them all up, and that gives me my answer of positive 9. Sigma notation.